In this video, we're going to do an overview of how the ALU works inside of our CPU. Now, from the reading, you should know the ALU takes in 16 inputs that we're going to call bus 1, and that will represent a 16-bit number. Now, we're going to label these inputs from 0 through 15. So we'll call the first one on the right side bit 0, then bit 1, 2, 3, all the way up to bit 15. Now this is called the least significant bit, and 15 is called the most significant bit. We're going to have another 16 inputs for bus 2, and we're going to number them in the same way. Now those are inputs, and then bus 3 becomes our output. And so we have 16 bits of output, and we're going to label them, again, 0 through 15. We also have some more inputs to tell us what operation we want to perform on our two 16-bit numbers. We can add them together, we can subtract them, take the 2's complement. Now 2's complement means that we only need one input, and we're going to take the 2's complement of bus 2 and ignore bus 1. Then we can do a bitwise AND or a bitwise OR. And what that means is we take this bit and this bit, we AND them together, just do a logical AND operation, and the output of the AND goes to bit 0. So again, bit 0 and bit 0 get ANDed together to produce the output bit 0. Then bit 1 and bit 1 get ANDed together to produce the output of bit 1, and so on up to bit 15, and bit 15 get ANDed together to produce bit 15. The OR operation does the same thing except for with an OR operation, and that's called a bitwise OR. Now, NOT will negate or invert, basically take the zeros and make them ones, and the ones and make them zeros. And it will invert all the bits of bus 2. Then shift left only works on bus 1, and shift left takes this input right here and maps it to this output. So it shifts it over one bit. So bit 0 moves to bit 1 moves to bit 2, bit 2 moves to bit 3 moves to bit 4, and so on. Shift right is just the opposite. We move the bits this way. So bit 15 goes to bit 14, bit 14 goes to bit 13, and bit 13 goes to bit 12. And now bit 0 would just fall off and get ignored when we're shifting to the right. When we're shifting to the left, bit 15 just falls off and gets ignored. And there's more reading on what we'll shift in. If we're shifting the number this way, we will shift in a 0 that way. If we're shifting our number this way, then what we do need to figure out what our output is going to be, or what's going to get shifted up there. And we want to preserve the sign. So if we have a negative number and we shift it that way, we want to keep it negative. So we need to shift a 1 in there. If we're going to shift it this way, or if we're going to shift it this way and it's a positive number, meaning this is a 0, so the 0 gets shifted here, but we want to shift in another 0 right here to keep the number positive. TRA1 is the most basic operation. It just takes whatever's on bus 1 and puts it to the output. So bit 0 goes to bit 0, bit 1 to bit 1, bit 2 to bit 2, and so on. All right, so we could do a whole bunch of logic trying to do all of this together, but we're going to simplify it, and we're going to create just one circuit, and we're going to call this the ALU bit. Now the ALU bit just does these operations, but only on one bit. So we can take bit 0 from bus 1 and bit 0 from bus 2 and feed them in for input to this ALU bit that can then produce bit 0 output. And once we create one of these, we'll just place 16 of them down. And I'm obviously not going to have enough room to draw all 16 of them, but we'll place 16 of these down, and we'll just copy them and place them down. so that we'll have 16 identical circuits. And each one will be in charge of producing 1 bit of output. And so with that, the inputs to this circuit right here, now remember, we're just kind of making a generic one. It doesn't know which bit it's going to get for input. So we're just going to call this bit that it takes in for input bit I, which is just a generic number. Then when we go to build the entire ALU, we'll say, okay, this ALU bit is for bit number 5, or something like that, whatever it is. What that means is that it produces bit 5 of output. Okay, so now whenever we see bit I, we see that that is bit 5. So for input, it will need to get bit 5 from bus 1 and bit 5 from bus 2. And then it can add bus 1 and bus 2 together, but just these 2 bits. And then it can also subtract, take the 2's complement, and or negate shift left, shift right, or TRA1. Now for the shift lefts and shift rights, this guy is going to need to spy on its neighbor bits, because remember, it has to produce bit 5 as output. So if we're shifting it to the left, that means that bit 4 needs to go to the output of bit 5. So this guy is also going to spy on bit 4 so it can shift to the left, and spy on bit 5 so it can shift to the right. Now also, as inputs, we will take in the operation, so it needs to know what it does with those 2 bits. Now these operations will also go to all 16 of them. So each one of these ALU bits is in charge of doing all 9 operations on a single bit. And for input, it needs to spy on the 2 neighbors, so it could do the shift left and shift right, but it's mostly going to focus on that single bit for bus 1 and that single bit for bus 2. So in the first lab, we're focused on making one of these ALU bits, and just one of them. Then when we've made one of these in the second lab, we're going to place 16 of them down, and Logisim's really easy with that. You can package this up into something that looks like a chip, and then you could just grab that chip and place 16 of them down inside of your circuit, and then we can connect up the correct wires, basically assigning what I is, what bit I or that specific circuit will operate on. So that's how we're going to do the ALU, create our ALU. So watch for a lab that's going to talk about how we're going to build just one of these single bits, or watch for a video that will show you how you can build one of these bits. And then there'll be another video to show you how we can place 16 of them down and complete our entire ALU.